Hello and welcome back to my channel, your go-to spot for making maths super simple. Today, we're diving into something really important, indicial equations, or what some people call exponential equations, because they involve powers, also known as indices. So grab your notebook, let's get started. First things first, what is an indicial equation? It's simply an equation where the unknown appear as the index or exponent of a number. For example, 2 raised to the power of x equal to 8. Now, this is referred to as an indicial equation because the unknown here is the power. Take note. Now, for you to be able to solve indicial equation, there is one main strategy, which is to make the base the same. Note, it is super important for you to already know the laws of indices, and I will encourage you to watch my video on laws of indices, because for you to be able to solve initial equation, you have to be able to make the base of your equation the same. And to do that, you have to apply all the laws of indices. Let's take some examples. Example 1. 3 raised to the power of 2x minus 4 equal to 1. Now, the base of this equation are 3 and 1. How do I make the base the same on both sides of the equation? Remember that there is a law of indices that says a raised to the power of 0 equal to 1. A raised to the power of 0 equal to 1. It means that I can make this 1 become 3 raised to the power of 0, because 3 raised to anything raised to the power of 0 is 1. Then I will have my left hand side to be 2x minus 4. The two bases are now the same. I will just simply take out the base, then equate my power. So I'm simply left with 2x minus 4 equal to 0. And I'll solve the equation as 2x. Taking minus 4 to the other side of the equation becomes 0 plus 4. That is 2x equal to 4. Dividing both sides by 2. X will simply be equal to 4 divided by 2 is 2. That is, the answer to x is simply equal to 2. Let's take another example. I have 16 raised to the power of x equal to 1 over root 2. Now, the base on both sides are 16 and 1 over root 2. So I need to look for a way to make sure that the two bases are the same, because that's the only way I can solve the equation. Now, how do I do this? 16 can also be written as 2 times 2 times 2 times 2. That is 2 in 4 places, which is the same thing as 2 raised to the power of 4. So I can rewrite 16 as 2 raised to the power of 4 in bracket x raised to the power of x equal to, now don't forget the rule that says that 1 over a is equal to a raised to the power minus 1. So I can write this as square root of 2 raised to the power of minus 1 as being this. So 1 over anything is minus 1 of that same thing. Now, the base are still not the same thing. This is 2 and this is root 2. There's another rule that says that nth root of a is equal to a raised to the power 1 over n. So if I have square root of 2, it is the same thing as 2 raised to the power of 1 over 2, because square root is the same thing as power of 1 over 2. So I can rewrite this as 2 raised to the power of 4 into x equal to, this root 2 can be written as 2 raised to the power of 1 over 2 raised to the power of minus 1. Then I will multiply my power. 4 times x will simply be 2 raised to the power of 4x equal to 2 raised to the power of minus 1 over 2. Now the base are now the same, so I can cancel the 2 base. I'm left with 4x equal to minus 1 over 2. If I divide both sides by 4, x will simply be equal to, now minus 1 over 2 divided by 4 is the same thing as minus 1 over 2 multiplied by 1 over 4. which is the same thing as minus 1 over 8. So the answer to x is simply negative 1 over 8. Let's take another example. I have 81 raised to the power of 3x plus 2 over 243 raised to the power of minus x equal to 3 raised to the power of 4. Now, on the left hand side of my equation, there are two bases there. On the right hand side, there is one base. So I want to be able to make sure that on the left hand side, there is only one base. How do I do this? There's nothing I can do yet, but I can break down 81 into 3 multiplied by 3 multiplied by 3 multiplied by 3. That is 3 in 4 places will give me 81. So I can rewrite 81 as 3 raised to the power of 4 into 3x plus 2 over, I can rewrite 243 as 3 times 3 times 3 times 3 times 3. That is 3 in 5 places. That's 3 raised to the power of 5. So 243 can be written as 3 raised to the power of 5 into minus x equal to 3 raised to the power of 4. Don't forget the rule that says that a raised to the power of x divided by a raised to the power of y is the same thing as a raised to the power of x minus y. So I'm going to subtract the power. But before I do that, I can multiply my power to become 3 raised to the power. Now 4 times 3x is simply 12x plus 8 over 3 raised to the power of 5 times minus x is simply minus 5x, which is equal to 3 raised to the power of 4. This simply gives us what? 3, I've taken 1 of the power, so I have 12x plus 8 minus negative 5x. So I subtracted the powers equal to 3 raised to the power of 4. Now, I am left with what? 3 raised to the power of 12x plus 8 minus times minus is plus 5x equal to 3 raised to the power of 4. I now have same base, so I can cancel out my base. Then my equation becomes 12x plus 8 plus 5x equal to 4. 12x plus 5x is 17x equal to 4. If plus 8 comes to the other side, it becomes minus 8. So I'm left with 17x equal to minus 4. Then if I divide both sides by 17, x will simply be equal to minus 4 over 17. And that's the solution for x. X is simply minus 4 over 17. Let's take one last example. If I have 16 raised to the power of 2p minus 3 multiplied by 4 raised to the power of 2 minus 2p equal to 2 raised to the power of 4. Note, the bases here are 1, 2, and 3, and I have 2 bases on the left hand side. So I want to be able to have only one base on the left hand side. So how do I do this? At first, I cannot join the base together except they are similar. So what do I do? 16 can be written as 2 raised to the power of 4. Don't forget that I already have 2p minus 3. Then multiplied by 2 raised to the power of 2 minus 2p equal to 2 raised to the power of 4. So this will just simply be 2 raised to the power of 4 times 2p is 8p. 4 times minus 3 is minus 12. Multiplied by 2 raised to the power of minus 4p equal to 2 raised to the power of 4. The rule of indices that says that a raised to the power of x multiplied by a raised to the power of y will simply be equal to a raised to the power of x plus y. So I'm going to add up my powers here. I'll simply have 2 raised to the power of 8p minus 12 plus minus 4p, which is equal to 2 raised to the power of 4. So I have similar base, or I can still break it down as 2 raised to the power of 8p minus 12 plus times minus is minus 4p, then 2 raised to the power of 4. So I can now cancel my base. I am left with 8p minus 4p equal to 4. minus 12 goes to the other side, it becomes plus 12. So 8p minus 4p is 4p equal to 16. Dividing both sides by 4, 4 will take out 4, so p will simply be equal to 16 divided by 4 is 4. So p in this case is simply equal to 4. Practice time. Kindly pause the video and try out this practice question. Let's have a quick recap. Indicial equation involves unknown in the exponents. Try to express both sides with the same base. Once the bases are the same, just equate the power. If you found this video helpful, please hit that like button, subscribe for more Maths Made Easy, and share this video with a friend who is struggling with indices. Thanks for watching and see you in the next one.